All right, so as promised, we are going to kick out some derivatives of the product rule using the product rule. So just let's not forget, the product rule basically says the following. It is derivative of u times v is u prime v plus v prime u. Don't be scared, u prime just means derivative of u. And v prime is, oh yeah, the derivative of v. I know, right? Craziness. Note to self, I always like to write these trig functions over here because the derivative of these trig functions sometimes come into play. All right, here we go. So f prime of x. And like I said, f prime is just the derivative of f. Okay, that's what those mean. Okay, so if I'm going to try to find the derivative of f, it's f prime. I can call it df dx, either one, right? So here's my u. And there's my v. Now, like in the last video, we just talked about the power rule, right? That square root is actually x to the 1/2. So the 1/2 comes down because remember, we're doing u prime. Then I have x to the negative 1/2, right? Times v. So my v is going to stay the same. So v I'm going to just leave in black. X cubed minus 2, right? Then I'm going to be like, okay, plus, here we go. Now it's v prime. So now I'm going to take the derivative of the second one here, right? So the derivative of x cubed minus 2 is just 3x squared. Again, that's the power rule kicking in. And this time the square root of x is left alone. Okay, so you can leave it like this. Believe it or not, it can be left like this, or we can actually simplify it. Okay, if I simplify it, it's actually going to look like x cubed, sorry about that, x cubed in the numerator and 2 square roots of x in the denominator. And then over here is actually 3x squared radical x, 3x squared radical x. Okay. Now, one thing you can do, and I am taking a trip down my algebra 2 ways, right, is I can find a common denominator. The common denominator here is technically 2 square roots of x. So I'm left with x cubed minus 2 in this first numerator. But this guy over here, he doesn't have a denominator, so he needs the whole 2 radical x. So I'm going to multiply 2 radical x times 3x squared radical x. Okay, I know this is not calculus, but sometimes the algebra part is what kicks people up, okay? So square root of x times square root of x, oh yes, is x, right? I have a 2 times a 3, you know that's called 6, right? So now I have 1x, and I have 2 of those x's, so I have 6x cubed. Fun fact, check it out. I know you're so excited. Me too. That becomes 7x cubed minus 2 over 2 square roots of x. All right, so if that just blew your mind, go back, go back, go back. All right, and I'm hoping that right here, you're like, oh yeah, I know how the math dealer got that. Right, what I boxed in green. That is a 3, by the way. I know it doesn't look like a 3, but it is. Okay, remember, negative exponent, slid it down to the bottom, right? Now, I am literally adding fractions. And you know how to add fractions, right? Way back in the day, you had like 1/2 plus, 3. Okay, and that became 1/2 plus 6/2. Because you basically took that up there and got that. And that's what I did here, right? I multiplied that up there because it needed all of it. That's where the 7/2 came from. All right, so if that doesn't make sense to you, hey, guess what? I actually have a video on fractions. I know, crazy. Anyway, all right, back to the calculus because that's really what you're here for. F prime, here we go. Here is my U. There is my V, right? Oh, my U looked like a V. Sorry about that. A little sketchy. All right. Okay, so derivative of U. 1/3 comes down in front. Bam, because just remember, right? That's x to the 1/3. 1/3 comes down in front. Bam! Took a lot of effort to get down in front. Now I take away 1. Take 1/3 minus 1. Yep, you heard it. 2/3. You've seen pictures. So anyway, sine x. Then we go plus v prime, right? V prime. Derivative of sine. Well, that's up here at this table. I don't know. My table's off the chart. But anyway, derivative of sine is cosine. Love that one. All right. Times my u, which, yeah, is the cube root of x. Okay. Like I said, you could technically leave it like this. If you're just trying to find the derivative, you could leave it like this. If your teacher's like, we like to make it a little bit cleaner, yeah, then you could just kick this guy out as such, right? And then like earlier, you can get a common denominator and move along in life. All right, now check out this next one. This next one, actually, you could technically Multiply that out. Yeah, you've heard of it before, right? That FOIL process, although foiling just stands for multiplying the first, the outer is the inner, and the last. But the rule here is the product rule. They did ask you to do the product rule. So I'm going to kick this thing out in the product rule. Take note, that is actually x to the negative 2 minus 3x to the negative 4. Okay, so in blue, I'm finding the derivative of that. Negative 2x to the negative 3, because remember, power comes down in front. He loses the power. Negative 2 minus 1 is negative 3. Again, negative 4 comes down in front, gives me a 12. That becomes x to the negative 5. Okay, then times the second. So that's x plus 5x cubed. Then we go plus, right? Derivative of the second. Well, derivative of that one's a little bit easier, right? 1 plus 15x squared times the first, which is my 1 over x squared. I'm just going to call it x to the negative 2 minus 3x to the negative 4. Okay, technically that is the answer. Okay, it really is. I know people like freak out about that, but really that is. Now, if your teacher wants you to clean it up, well, that's when that foiling process comes into play. So I'm going to go ahead and just foil this thing out for no apparent reason. Okay, just because maybe I have a couple extra minutes. I don't know. But if your teacher's like, no, that's fine, then leave it. Just leave. Move on, right? X to the negative 3 times x to the first gives me x to the negative 2. When I multiply my negative 2 times 5, I get negative 10. X to the negative 3 and x cubed cancel to be x to the 0, so I don't even have an x there. It's very exciting. Okay. Now, kick in the next one, right? So that gives me 12 x to the negative 4. And then when I multiply this, negative 5 plus 3, because when you multiply like bases, you add those exponents. This gives you 60 x to the negative 2. And then likewise, over here, FOIL this guy out, right? It gives me plus 1x to the negative 2. So you're thinking, oh, I can combine. I know, I'm excited too. Minus 3x to the negative 4. Yep, I can combine with that guy. And then, fun fact, x squared and x to the negative 2. See ya. What more to be ya? And then when I multiply 15x squared times negative 3x to the fourth, that gives me negative 45. I'm going to be really neat here. I lied. Negative 2. Now, cleaning house, right? Negative 10. I think I had a 15 over there. All right, so that gives me a 5. I hope I don't mess these up. So see ya, right? Then I have, let's do a negative 4. So I have 12x to the negative 4, and I have a negative 3x to the negative 4. So yep, that makes 9x to the negative 4. I'm looking at my handwriting. Sorry. Now look at these guys. I have x to the negative 2 and x to the negative 2 and x to the negative 2 and x to the negative 2. I have a lot of x to the negative 2's, right? So I like to do things a little differently. I have a 60 and a 45. That makes 15, right? I have a 1 and minus 2, so that makes a minus 1. So it looks like I'm going to get a 14x to the negative 2. And I think I got them all. And there's my f prime. And of course, if you're looking at an answer key, that answer key might actually have it written like this. But you're not scared? No, siree. You're dealing with a math dealer. All right. I hope this was helpful. If not, maybe I'll make some more. Anyway, all right. Have a fabulous study